with respect to t and set the sine term equal to 1, which is its maximum, and we get the maximum rotational speed. And if we have the maximum rotational speed, we can plug that into our rotational kinetic energy formula, 1/2 times the moment of inertia times the rotational speed squared. If you square that, this square root goes away, and you have to square c sub 0. But the c sub 0 is not very important. You could just use use a change of variable. You could use change of units and set it equal to 1. So that's sort of arbitrary as well. Let's go to the next page. Go ahead. Why is it not letting me do this? No. Now the length of this segment can be calculated. The way I did it was I created an expression for the slope of the line segment between M1 and M2. So the slope is rise over run, and then I can solve for the point of intersection here, and I get L equals 2R1 R2 divided by R1 plus R2 times sine phi over 2. Right? I wish that, I don't know why this doesn't let me do anything. Alright. Alright, next page. It's irritating. Alright, so a pendulum with length L, which we calculated before, and mass M1 plus M2. So in other words, if you took the pendulum and you sort of squished the two masses together and attached them to a rod of length L, then you would have a pendulum which has the following equation here. Okay, and we can do the same thing. We do small angle approximation, and the maximum rotational speed is given to be this. And notice this is just the reciprocal of the other term, multiplied by C0. So the omega term here is the reciprocal of the omega term in the previous equation. And so we get the following maximum rotational kinetic energy. And if you do the algebra, you can see that so this is equation 3. Equation 3 is equal to equation 2. No, that's not equation 2. This is equation 2. So this equation is equivalent algebraically to this equation. And so that proves that the maximum kinetic energy, rotational energy, is equal in the case where you have a pendulum with mass M1 plus M2 and a length L, and the system where you have the two arms of length R1 and R2 and mass 1 and mass 2. So because the rotational energies are equivalent, you do not have extra kinetic energy. So that